All right, we're starting the next unit. We are doing Learning Plan 2.1, which is in our textbook is Chapter 3, and we're going to start out with the rectangular coordinate system. Today we're going to interpret a line graph, plot ordered pairs, find ordered pairs that satisfy a given equation, graph lines, find intercepts, recognize the equations that are horizontal and vertical lines and lines passing through the origin, and then use the midpoint theorem. So we better get started, huh? How do you interpret a line graph? Well, let's look at a line graph and see how we would interpret it. This is close to a line graph. If you notice up here near the top, it kind of has a little bit of a quirky thing. Oops, why did that not? Let's go forward here. Here near the top, it's kind of got a little bit of a change, but the rest of it is pretty close to being a line. Locating a point on the line like this was developed by René Descartes, and that's why we call them Cartesian coordinates. These along this side, in this case is spending, we call the y-axis. These along this side, in this case years, we call the x-axis. Then when you graph it, you get a straight line. So how do you go about plotting ordered pairs on a graph like that? Well, let's plot these points and see exactly how you would do it. Notice we've got the x-axis and we've got the y-axis both. And then where the two meet is called the origin. So in the first case, we're going to go, the first coordinate is x, the second one is y. It matters which order you do them. So we go over 3, up 2, and that's the first point. Back 5, down or up 6 is that point. Forward 4, down 1 is this point. So you see how those 3 points are graphed here on our axes. The first point, 3, 2. The second point, negative 5, 6. And the third point, 4, negative 1. Okay. And there you see some points listed, and then we would just give their coordinates. The point A was forward 3, 1, 2, 3, up 1, so we give it the address 3, 1. The second point B is forward 4, down 1, so we would write for negative 1. In every case, we'd go the x distance first and the y distance second. C, D, and E are graphed accordingly. So, the other thing that you'll notice is in this graph, we've got quadrant 1, 2, 3, and 4. The points on the x and y axis are not actually in any quadrant. Are you ready? Let's go on. So, you do these questions, and when you're ready, press play, and I'll show you how I did them. Okay, so it says x times y is greater than 0. That means either both of them are positive or both of them are negative. That's how you get a positive answer. For letter B, it says x times y is less than 0, which means either the first one is positive or the second one is positive, but in each case the other one is negative. The next one, divided by, Okay, when you see divided by and it's less than 0, that'll fit into the same category, these two quadrants, and then being greater than 0 is back to the ones that I shaded in green. Let's look at the next set. What must be true about the value of at least one of the coordinates if it lies along the axes? So if it's one of these points along here, then that letter, either x or y, equals 0. Of course, if it's along this line, then x is 0, and if it's along this line, then y is 0. Page 137 asks us to find an ordered pair that satisfies a given equation. How do you go about doing that? Well, the example they give is 2x plus 3y equals 6. We want to find numbers that match those two spots. Now, what they mean by saying that is they want the answer to be true when you substitute those in. So, let's look at how we would do an example like that. Here's an equation, 3x minus 4y equals 12. We're supposed to complete the table. I'm sorry, I must have erased some of the numbers. Let's make this one 2, and this one 6. Okay, so if in the first case, if x is 0, we've got 3 times 0 minus 4y equals 12. This cancels out, so negative 4y is 12, means y is negative 3. For the next one, 3x minus 4 times 0 equals 12, so this cancels out. 3 times what is 12? 3 times 4, so x is 4. Next one, I just arbitrarily chose 2. 3 times 2 minus 4y equals 12. 3 times 2 is 6. So subtract 6 from both sides, you get negative 4y equals 6. So y is negative 3 halves. Last one, 3x minus 4 times 6 equals 12. Let's say this is, 24? So we're going to add 24 to each side. We get 3x is 36, or x is 12. So that's how you fill in the table of values like that. Let's look at the next one. And you try this, and when you're done, I'll show you how I got it. Okay, so we fill in 0, 0, 4, 2. 2 times 0 minus y equals 4. This cancels. Negative y is 4, so y is negative 4. 2x minus 0 is 4, so 2x is 4. Divide both sides by 2, x is 2. 2 times 4 minus y equals 4. Subtract 8 from both sides, and you get negative y is negative 4, so y is positive 4. And in the last case, 2x minus 2 is 4. Add 2 to both sides, and you get 2x is 6, so x is 3. Let's go on to the next one. Complete this table for the equation, and when you're ready, I'll show you how I got it. So 2 plus y is 5. 2 plus 3 is 5. Next one, 5 plus y is 5, so y must be 0. Last one, 0 plus y is 5, so y must be 5. So the correct answer, 305, is letter A. So how do you go about graphing lines? That's the objective 4. I'm on page 138. The graph of a line is a set of points corresponding to all the ordered pairs that satisfy the equation. It gives a picture of the equation. So here's an equation. Notice these are the variables, x and y. A, b, and c are all real numbers. We just don't specify what they are. And they can't both be, a and b can't both be 0. When you have both letters on the same side, it's called the standard form. So, we use the standard form to find x and y intercepts. A straight line is determined if any 2 points on the line are known. So if you have 2 points, you can make a line. The x-intercept is the point, if any, it doesn't have to, but it usually does, where the line intersects the x-axis. The y-intercept is any point where it intersects the y-axis. Okay, so how do you go about doing it? Well, what's interesting is when you graph a line, to find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0. Here's the way I do it with an equation like that one that we had for ax plus by equals 0. What I would do is something along these lines. Let's take an equation, 2x plus 3y equals 6. So when I let x be 0, basically what I do is I take my finger and I cover up the 2x. I'm just showing you that I covered up. So in other words, x is 0. Y would be 2. Why? Because that first part is missing, and so you have 3y is 6. Then, when I want to find the y-intercept, the y-intercept, I'm going to change colors here so that you can see what I'm talking about. I cover up the y with my finger. Here's my finger. And when I do, I notice that 2x is 6. 2 times what is 6? 2 times 3. So then I've got both of my intercepts, over 0, up 2, over 3, up 0. I've got 2 points. I can just draw the line. So with the standard form, I remember to use my finger to cover it up. Here we go. While 2 points is sufficient for a straight line, it's a good idea to use a third point to guard against errors. So let's do it with this equation right here. 2x minus y equals 4. So I cover up the x with my finger, and negative y is 4, so y is negative 4. So if x is 0, y is negative 4. Now I'm going to cover up the y with my finger, so 2x is 4, so x is, what did I just do? X is 0, y is negative 4. I'm sorry, I made a mistake there. And then y is 0, x is positive 2. So my line goes through those 2 points right there. 2x minus y is 4. Next one. I'll let you do this one Okay, so I've got my points. X is 0, y is 0. Cover up the x. Negative 2 times what is 4? Negative 2 times negative 2. Cover up the y. X is 4. So over 4, up 0. Over 0, down 2. And there is my line. Next one. This one's actually a little tricky, and that's because you still get the 0 and 0, but when you cover up the x, 4y equals negative 6, so y is negative 2 or 3 halves. Cover up the y, negative 2 times what is negative 6? Negative 2 times 3. So over 3, up 0, over 0, down 1.5. So my line is going to go like that. So that's how you find intercepts of lines. Let's look at the next section, which tells us to recognize equations of horizontal and vertical lines and of lines passing through the origin. Well, if you have a line parallel to the x-axis, it does not have an x-intercept. A line parallel to the y-axis will not have a y-intercept. So, in other words, if it doesn't go through the x-axis, I'm going to draw two of them here. If it doesn't go through the x-axis, it's going to be parallel to it, and if you notice, it's not crossing the x-axis. There's a line parallel to the y-axis. In each case, in this equation, y will be some number. In this equation, x will be some number. So a vertical line has the equation x equals some number. In a horizontal line, it has the equation y equals some number. How do I know that? Well, I know it because I'm crossing and I get this point right here. And I get this point right here. Which, if I were treating this like a number line, okay, this would be the y number line, correct? Okay, so I'm going to kind of turn my paper sideways so that here's my y number line, correct? Y equals, I'm going to go across the y-axis. The x number line is real easy because you don't have to turn your paper. You've just got the x-axis right there, and so you will have a vertical line has an x equals, a horizontal line has a y equals. Let's look at the next one. So how do we graph y equals 3? Well, I put a dot at 3 on the y-axis. Now, I'm not going to go up and down through that point, so I must be going left and right through that point. How do I know? Well, if I were going to cover up with my finger, I would have no x to cover up. So it doesn't cross the x-axis, so I don't have any number to put along that line. Okay, so if I tried, x is 0, y is 0. Okay, well, if x is 0, y is 3. But if y is 0, 0 equals 3, you can't do. There is no solution. So you can't cross the x-axis. You can only cross the y-axis. Okay, let's look at the next one. Alright, so you got your table of values. X is 0, y is 0. If x is 0, which it already is, y is negative 2. If y is 0, 0 equals negative 2, there is no solution, so it doesn't cross the x-axis. Means you have to go straight across. Next one. I'm sorry, we're not doing this over here. Okay, x is 0, y is 0. If x is 0, y is negative 6. If y is 0, 0 equals negative 6, there is no solution for that, and so we've got a horizontal line there. Alright, here's another equation with a vertical line. Notice we've got the table of values, x is 0, y is 0. And when we do put in 0 for x, we would get 2 equals 0. There is no solution, correct? Put 0 in for y, you get x plus 2 equals 0, or x equals negative 2. Oops, I did that wrong, didn't I? Sorry about that. X is negative 2. So x, along the x-axis, we go through negative 2. Y, we don't go through at all. I made my line wrong there. Got so used to drawing those horizontal lines, I forgot that it's a vertical line if you have x. So you graph this one. Well, you've got a table of values. X is 0, y is 0. 0 plus 3 is 0? No. There is no solution, so you never cross the x-axis. If y is 0, x is negative 3, because negative 3 plus 3, x is negative 3. So we've got a vertical line here at negative 3. Next one. Got our table of values. X, y, 0, 0. If x is 0, 0 equals 3, there is no solution. If y is 0, x is 3. So we put a dot on the x-axis. X is 3, means we're going to do a vertical line through 3. So that's basically how we do horizontal and vertical lines. We run into a problem if we try using the table of values when we get to an equation where we've got x and y, and we try 0 and 0. Because if we put 0 in for x, we also get 0 for y. So if you notice, we didn't graph 2 points, we ended up only graphing 1 point. Now there's a number of ways that we can do this problem from here. I think the easiest way to do it is to write 3x equals y. In other words, move one of the letters to the other side. Okay, now when we choose a number, we're going to substitute whichever number is multiplied as 1. 3 times 1 is 3. So we're going to go over 1, up 3, and there is our other line. That works most of the time. This is one of the cases that it doesn't work, and I'll show you why. Because you still get, if you try 0, you get 0 in each case, so you've only graphed one line. Now when you rewrite it, 2x equals negative 3y, right? I switched the 3y to the other side, and that makes it negative. Notice I can't, make one of them 1, but if I make the first one 3, 2 times 3 Where did I get that from? Right here. I made it 3. I could have even made it negative 3, but I'm just going to make it 3. 2 times 3 equals negative 3 times what? So if x is 3, y will be negative 2. So over, from there, x is over 3 down 2. There are my 2 points, and now I can graph the line. So that's an easy way to graph lines that pass through the origin. So I choose a multiple of either coordinate. I could have done it the other way. I could have said negative 3 times 2 on that side, and I would have still gotten the other side 2 times x. So negative 3 times 2 is negative 6. 2 times what is negative 6? 2 times negative 3. So x is negative 3 when y is 2. Back 3, up 2 puts us through that point right there. Okay. So that's basically how you do that. You try this one. Obviously, when we do our table of values, 0, 0, we get 0, 0, so we've only gotten 1 point so far. Get our letters on opposite sides. Choose a coefficient. So for x, I'm going to make it 20. So 4 times 20 equals 20 times y will be 4. So if x is 20, y is 4. Over 20 up 4 is the same as over 10 up 2. So there's my, oops, I didn't get that line drawn correctly. There's my line. All right. Last thing that we've got for this lesson is the midpoint. The midpoint of a line segment is the point that divides the line exactly in half. The line segment exactly in half. It's also considered the average coordinate. How do you find the average? Well, you add them up and divide by 2. So the midpoint of the line segment, x sub 1, y sub 1, and x sub 2, y sub 2, is x sub 1 plus x sub 2 over 2, y sub 1, y sub 2 over 2. So the midpoint of the segment PQ, 5, negative 5, plus 2 over 2, 8 plus 4 over 2. Negative 5 and 2 is negative 3 over 2. 8 and 4 is 12 over 2, which is 6. So the midpoint of that segment is negative 3/2, 6. You try this one. Okay, so halfway between 2 and negative 4 and negative 5 and 7. 2 plus negative 4 is negative 2 over 2, which is negative 1. Negative 5 and 7 is 2 over 2, which is positive 1. So our answer is negative 1, comma, positive 1 is the midpoint of that segment. Last one. Okay, so we add them up. 2 plus 3 divided by 2, and 9 plus 1 divided by 2. Remember that we're doing the first coordinates and the second coordinates. This is 5/2. 9 and 1 is 10 halves, which is 5. So our answer is 5 halves, comma, 5. Remember, it's an ordered pair, and so that is the answer to this question. If you have any questions, you can give me a call. Otherwise, I'll see you next time. Have a good day. Bye now.